what's up? I'm Cassandra with On Point Scans, and I have Jake
Spazzaro.
I get it wrong every time with me, my co-host from Evolve Lab. Just to begin out with, I want to make sure you can hear me. So in that chat box, if you could just confirm that you can, everything else looks good to go. Let's see, there's always a little bit of a delay.
Let's say this is. Okay, I think we're
Good to go.
We're
Yep.
good to go.
Awesome. Sweet. So a little bit to begin with, I'm with On Point Scans. We're a sister company of Evolve Lab, and essentially what we do is 3D capture. So we're out there scanning using photogrammetry and LiDAR to scan as-built buildings and do 3D modeling out of that. And then my counterpart, Jake, is with Evolve Lab. You want to explain Evolve Lab?
Well, Evolve Lab does many things, but we do BIM coordination, and we do computational design and everything that could be encompassed within the BIM world. But I'm kind of a hybrid where I jump between the scanning at On Point Scans and Evolve Lab and kind of bridge the gap from scan to BIM, and that's kind of what we're here to talk about today.
Yeah, so we'll be showing a full workflow from scan to model. All right, so messing everything up.
So click on the first slide. There we go.
All right, I wanted to ask you guys how you're measuring as-built. Go ahead in the comment box. Let me know. Are you guys going in and doing hand measurements? Are you already doing some kind of photogrammetry or LiDAR? What are you doing on the job site? And while you guys go ahead and answer that, I'm going to have Jake explain who's using this service and why.
So we like to focus within the AEC industry when in terms of scanning, and the first huge thing, one of our biggest customers is architects, and there's so many uses for a 3D scan as an architect, and one of the big ones that we've been doing lately is creating as-built. So we're located in Boulder, Colorado, and Boulder has a lot of strict coding, and there's actually not a lot of new construction in Boulder. So a lot of it is really old homes, like late 1800s, early 1900s, and there are no drawings existing, and you don't just have something lying around to measure off of. And also what I've started to notice is that not everything is a straight shot in an old house. You could have a wall with a little wave in it, or the floor could have something, and ceilings. So what we do is we go in with the scanner and scan the entire building within a couple of hours. And then in 2 hours, you have the entire building ready to be measured. You have it captured. You can walk away. You don't have to go back if you miss anything because you have it all. And architects and design build people in Boulder are using that information to create their as-builts in Revit, and then design off of that. And it's been amazing. And then I personally come from a general contracting background and also a subcontracting background in mechanical and plumbing. And we use scanning. So if we're remodeling, say, a mechanical room, and you have all your hydronic piping and you have your chillers and everything, and that's a complicated layout, and that's also a hard thing to go out and field measure. But you can go out there with a scanner and scan the entire room, and then you know where every chiller is, you know where all your pipe is, you know bottom of pipe, top of pipe, you can see the insulation, you can see where the hangers are, and then you can go in there and actually begin to redesign that incredibly easily. I mean, it's one thing to measure walls in a house, but to go out there and measure the bottom of hundreds of pipes and take off all those takeoffs, I mean, in 2 or 3 hours you have everything, and it's done, and it's cheap, and it's easy, and then it's always there for you. Another huge thing that this can be used for is facility management, and Cassandra's got a really cool walkthrough that she's going to go through with you later. But being able to scan your office or your factory or data center, and you can actually tag elements. You can tag a computer, you can tag a light. So you can take a light, you can say, well, this is what kind of light bulb goes in there. You click on it, or you can tag a wall and say, what is this paint color? I'll just click on it, and then it'll tell you what paint color it is, and you can have a link to buy it. So facility management is revolutionized. Once again, within a couple hours, you scan the space, you get all the data, and then you go through and tag it, and you can hand that off from every time you have a new facility management person, they can just pick that up and run with it. And then just like a little cool thing I've been seeing a lot on LinkedIn is historical preservation. You see all those cool scans in Rome. Like you, Cassandra was just in Rome. I just did my honeymoon in Rome a couple months ago, and you see all those ancient artifacts, and being able to scan them and preserve them forever is huge.
Yeah, amazing. In case anything ever happens to that, you have an exact replica.
Yeah, you have it, and it's there, and it's saved. And so I'm just super excited about scanning. I think it's awesome. It's really cool. I think we're going to go back now.
Yeah, so how you're measuring as-built. And I had a couple responses. We had some BLK and Matterport. We use what the architect gives us. I get that a lot.
Well, see, Adam there with the MEP trades, what I was talking about, having to remodel and going off of that. So you don't have to, you can always verify it now in the field, which is great.
And then old drawings, which we can't read. Revit, Recap.
Those are the best.
And I don't know what RCS is personally.
RCS is the output file. So you get like a .rcs file that would go into Revit.
That's why I brought him.
Yeah, that's...
And then that's it. So one thing I always like to stress is if you are doing hand measurements or you're going off old documents, you generally have a hard time with things like time in general. Our coworker, who's not here currently, did a project with CU Boulder, and they were remodeling a building. The students took over 60 man-hours for multiple students to measure the building, when we could go in and do that in minutes with a scanner, or a couple hours depending on the size. And then accuracy. Hand accuracy does not compare to using some kind of scanner, as well as sometimes you just miss information altogether.
Exactly. So I want to talk about kind of the foundation of why you would do a scan is to end up with something called a point cloud. And most of you probably know what that is. But a point cloud is a set of data points in space. Point clouds are generally produced by 3D scanners, which measure a large number of points on the external surface of an object. So to scan something, let's say I've got my handy iPhone here. So when you scan an object, you would get hundreds or thousands of little points that would encapsulate the object. And each one of those points create a cloud, and that is what you use to model off of. So you could, all around the edges, you'd get hundreds of points that would follow the edges, and you'd be able to pick a point and measure from that. And that point cloud data, it creates what you call like a mesh or whatever, that you use that information. So it's not actually a solid object, it's thousands and thousands of little points
that are XYZ coordinates.
That are XYZ coordinates that create the shape of whatever you scanned.
Yep. So we're going to talk really quickly about photogrammetry versus LiDAR. So photogrammetry, I like to explain it as you take a photo.
I love those arrows.
I drew those myself.
Did you?
And you turn it into measurements. So photogrammetry is the science of making measurements from photographs. So fun fact, the term photogrammetry turns 141 years old this December. Pretty much as soon as the first camera was invented, people were thinking about using this for civil engineering in Germany.
Which blew my mind. I argued with her for about a half an hour yesterday in the office saying that that's not true.
Photogrammetry is older than you think. Alright, so we're going to focus on the Matterport. That's one of the tools that we're utilizing to make our scans. The benefits of using the Matterport is that it creates attractive, high-quality images, and we'll show you a couple of these walkthroughs in a minute. It creates beautiful, deliverable 360 tours, so you can actually walk through, make videos, all that fun stuff. And it can be turned into point clouds, so it's completely usable as well. It has an accuracy of within 1% of reality. It's quick. You can do individual scans that take about 30 seconds each.
Which is really nice. I mean, a Matterport, so a 2,000 square foot house, you could scan in an hour and a half with the Matterport and have the entire building captured.
Yeah. And you can model up to 200 scans at a time with the Matterport. So if you're doing a building over 10,000 square feet, you would end up with 2 models with Matterport anyways. So this first video I wanted to show you is a model of a house in Boulder, I believe.
Yes.
Laura Larson design. And if you just looking at this, it would have been a nightmare to go through and hand measure this. There's so many angles,
Yeah.
so much going on.
The geometry.
There's a rock in the house.
Quite the view.
Yeah, really cool. So all sizes of architecture firms are using this, small, large. It's super beneficial to getting those as-builts done. And then I also have a construction progress model. So basically what we're going in and doing is before the contractor puts up sheetrock, we go in and scan it so you have all those MEP systems exposed and you know exactly where everything is. This helps so much after construction, knowing where all that information is.
Well, you capture the MEP as-builts, and it's true. Like, it's not a guess, and it's not per design. Like, that is exactly where they are. And then you throw the sheetrock on, and you're good to go.
Yeah. And then the last one I wanted to show you with Matterport. This is the facility management model.
This is what we were talking about earlier, and I think this is one of the coolest underutilized things. Flip that over there. This is incredible.
So go ahead and drive, Jake.
Okay, so what we can see here is this is an office space, and we can click around, and then what is this? Then we have, so you hover over it, and this is a Mac desktop, and if you can click on the link, and it'll take you, this is the iMac 21.5 inch late 2015. Come over here. What is this wall? I mean, then, so like, what is this paint color? Follow our link here, and we have it. And you can go through your entire office space. You can see over here that we have lighting. I don't know. This just blows my mind. Being able to do this and have the cost. I mean, for someone in facility management to say, "Oh, this light bulb is burnt out. I need to fix it." Like,
I personally like this. I came from a GC background. A lot of facilities managers want a deliverable, but they don't know what to do with it. They're not utilizing Revit. They're not utilizing other software programs. This is a really intuitive online way to get that information to them.
and it's so simple.
Yeah.
You don't need to know how to use Revit or anything to do this. We would come and scan it, and then you can come through here yourself, or we can, and click through it and add everything.
Mm-hmm. So that's one other Matterport tool I wanted to show you. Now we're going to quickly go back to my PowerPoint and talk about laser scanning or LiDAR. I like to describe this like I would to a middle schooler or kindergartner.
It's like the Office episode, or it's like, can you explain it to me like I'm 5?
Yeah.
Okay, now like I'm 3.
Sonar. It's whales that use sonar, right?
Sonar? Yeah, we'll go with that. Or bats.
So LiDAR is basically a laser that bounces off an object and comes back, and it's measuring that distance. Pretty cool stuff. The tool we're using is the BLK 360. The advantages to this is it's highly accurate within millimeters at 10 meters distance, so it's even more accurate than the Matterport. It can scan exteriors of buildings. So the downside to the Matterport is you cannot scan exteriors.
But we've developed a workflow. No, we have to use the BLK within the Matterport interface and actually scan the exterior and mesh a Matterport interior scan with a BLK exterior scan and create one solid scan. And we're going to show you guys one of those later.
And LiDAR can have photography tied to it, so it's not always like just the point cloud. But be aware of what you're doing and what you're purchasing if you do want that photo applied to it as well, so you have the color and aesthetic, I guess you would say. So this is a really quick LiDAR scan we did. All of these bubbles you see, those are different scans. So we're just doing some
Those are
sectioning.
scan points, yeah.
You want to talk about this?
It's awesome. Yeah, so all the bubbles or spheres that you see are where a BLK 360 scan was taken. This interface you're seeing is Recap Pro, which some of you are probably familiar with. And if you clicked on a bubble, you would be taken to the 360 image, and then you can go ahead and follow them around. So it's pretty similar to the Matterport interface that we talked about, but you have the advantage that you're getting a LiDAR scan here, which is more accurate. But the Matterport is still very accurate, and most people find that, I mean, I would say on any residential project, like a Matterport is going to be more than enough, but if you get into huge 20,000 square foot commercial spaces with tall ceilings and long runs, that's probably when you would want to start looking at LiDAR to capture those longer spaces.
Really quick note, we do 3D modeling, so we do the whole process from scan to model if that's needed, but I actually want to give you some time to get into the stuff I don't know about.
Yeah, so in a little bit, I'm kind of going to go over in these next 3 steps, how do you scan a building, and then what does a point cloud look like inside of Revit, bringing it into Revit, and then like kind of modeling off of it, like you're saying, like we have this awesome scan, but how do we make it into a Revit model that we can use? So the first thing I want to talk about is just actually showing up with the scan. So we'll just say like a 2,000 square foot house, for example here. We would schedule a time with an architect or a contractor, whoever needs the scan, and then we would coordinate with the homeowner. And for the homeowner, like the client, they don't really need to do anything but not be there. Is the only like caveat. Like people and pets and movement will throw off the scan if the scanner. So it sits on a tripod and then it spins around in a 360 and captures the images as it spins around. So if anything walks in front of that scan, it'll throw the scan off. So an empty home, you don't really need to clean or anything. You just turn all the lights on, and then with a Matterport, you place it about every 5 to 7 feet. I would say a typical 2,000 square foot home is between 60 and 80 scans, which would take about an hour and a half. If you want to do the outside, probably another hour, I would say, and we would use the BOK to walk it around the outside. And then we would process it through the Matterport app, and then we would download a point cloud file off of that. I think it's an XYZ file, and we put it into Recap Pro and then convert it to an RCP or an RCS file, like I heard some of you mentioning in the comments, and then bringing that into Revit, and I'm going to talk about that. And the BOK 360 for the LiDAR, it's a super similar process. It's just that all of the scanning is processed through the Recap Pro, or we use the Recap Pro iPad app. And as you scan, you can just align those points. You get like 3 targets on the surfaces of the walls that you do. So that's the scanning process. It's super simple. Like I said, a 2,000 square foot house is probably an hour and a half. I did a 20,000 square foot restaurant bar in Austin, Texas, which was really fun. And that was interesting because the bar opened for brunch at 11 and it didn't close till 2 a.m. And then the cleaning staff was there from 2 a.m. to 4 a.m. So I had
hours.
Yeah, so I had a window between 6 and like probably 10:30, 6 a.m. and 10:30 to scan. So over 3 days, we scanned that whole bar, and it was super cool. It turned into this like massive file, but really useful information. So I kind of want to get into now going through like from Matterport to Point Cloud to Revit, if you don't mind.
Go for it. And just so you all know, I'm reading your questions. We will be answering those either as we go through or at the end.
Okay, so I'm going to start with so I wanted to show you guys. So this is the 3D space that I'm going to be using for the demonstration here. And this is the beginning, if you will. So this is what Matterport shows us that we scanned online. And then if you click into the space, you are inside the house and you can click around like we've shown and just get a visual idea of what's going on. And I really like this software because if you're inside a Revit and the point cloud is a little hazy, you're like, what is that up there? I can come into the Matterport app online, and I can clearly see like, oh, that's a vent, or there's a light switch, or there's an outlet. And then I can also get some details on the stairs, about balusters and whatnot. So we take this and we download, we do the Matter Pack. And this is a little different for the BLK. We would download, it would go straight into Recap, so we wouldn't have to do this. So we download the Matter Pack, which will give us an XYZ file. And then all you have to do is you open that XYZ file inside of Recap Pro and then just convert it to RCP. It's a super simple step, probably takes 10 minutes depending on the size. And then if I go into my links here inside of Revit, what I've done is I took the scan, the .rcs file is what I use, and loaded it into the project. And then here is that scan as a point cloud inside of Revit. So I'll just spin it around for you. We took this scan from the ground, which is why you're not getting the roof. It can be done. You would get a tall tripod and just kind of bring it up over the building, or you could use a drone. But you can also notice that we have the basement here, and you're also getting your topography contour lines and your fence line as well as the trees and stuff, which is just really great information. So once I bring the point cloud in, the first thing that I do is make sure that I've got my levels set up right. So you can see that I have the main level, and that's probably off a little bit, and then bottom of structure there, and then level 2.
How do you adjust that one?
So what I would do, because I would see that that's off, so I would take a section through it, and you can see that this is what I love about scanning, is that I can pull this section out, and you can actually see that depending on where you are, so here's the line, so then I can see right there, there's the floor, and I can actually adjust my main level to it, or I can grab the point cloud and I can move the point cloud to the main level, which is probably a better way to do it. And then, so this is how I would cut a section straight through, and now I'm able to see where the floor is at every level and define my elevations that way. So once I've defined my elevations, then I'm going to go to my floor plans, and I have some walls already in here, but if I go into my view range, what I want to show you guys is if I turn this bottom offset to 0 and hit apply, you can actually see the floor and everything in it. Let me hide all these guys. But that kind of gets hard to digest, you're like, what is going on? So I usually like to take the view range and cut it probably 2 to 3 feet above the floor, and that'll clean it up for me and actually give me a real clear outline of wall thicknesses, where the stairs are going, doors, you can see them kind of like swung open.
One thing I think we forgot to mention is when we do scans of residential homes, they don't necessarily have to move everything, so that's why.
Yeah,
the house doesn't have to be empty.
It doesn't have to be empty, and it's unrealistic to expect that too. So that's why we just work around it, and we get all the information we need too. One thing that I thought was really interesting. So this right here is a fireplace, and you can see that we've got this brick, and you're like, what's going on there? So what I did is you cut a section through it, and we'll pull it tight. And you can actually see that you've got your mantle there, and then your little block out on the bottom, but the wall is up there, and we want to get this wall thickness. So I know that I need to cut my level at least 4'5" above that. So I need to go to my view range, move this to say 6, and this to 5. And there we go, that wall tightens up immediately. So that's the thing when you're inside of Revit with these scans, is that getting this view range correct, cutting it at the plane you need it to, is like crucial to scan interpretation. And what I want to show you guys is that what I've done is just barely started to actually add some architectural features to this room. So when I go into 3D here, I can turn off my point cloud, in the view. And I actually have now an accurate as-built model of this home. And you can see that with this window here, I was able to basically replicate exactly what was already there by going into the floor plan, and I took this section view, and you can actually see, if I hide this, the window that was there. And you can measure the window with your measuring tool and say it needs to be 4'8" and 5'64", and you can modify then your families to fit that and encompass that space. And I want to go over, so I added the walls here, and this is one of the coolest things that I think would take a really long time to measure in the field, but with a scan, it's no problem. So if you see this archway here, so if I click, I have a basic wall in this space, but I don't have the archway cut out of it. So if I edit it, I can come in now and I'll grab a line, and following the outline of the scan, and this takes a little bit of tinkering to make sure you get it deadly accurate, but the information's all there for you. So now I'm going to take...
So we got your markup, so we're going to be moving this graph
and this isn't going to be perfect, but it's going to be close, and you can totally spend the time to make this perfect. And then all I need to do here is add one last line. So now I have that wall, that opening cut out. And if we go into the 3D view and we hide the point cloud, you can see, I mean, how cool is that? Like, how long did that take?
Not long at all.
Less than a minute. A perfectly accurate cutout. You didn't have to measure the angle in the field. You didn't have to pull it. I mean, it's right there. It's ready to go. I did the same thing with this door opening here. I did the same thing with this window. And that's the power of all this data being encapsulated into there. So I'd personally love to just kind of scroll through the questions now and kind of make sure that we're hitting everything people want to hear about.
Let's see. Does it capture real world coordinates from... I'm not going to try.
No, it won't capture real world coordinates, but one thing that you can do is Autodesk has a software called InfraWorks, which you can go in and you can say, this is the lot. I don't know if they use Google or Bing Maps, and then you can take your point cloud scan and drop it in that space. And based off of trees and things that you scanned and curbs, you can align it perfectly to where it is, and then bam, you got your coordinates that you need. And you can actually do planning then in the space and see how you're going to affect the surrounding area.
What software to view the scans, Novice? So you can actually use, within Autodesk products, you can use Recap, Revit, AutoCAD, Civil 3D, of course.
I don't know if it'll go into Navisworks. I don't think
know
it will.
About that one. I've also used it in...
You've got the Matterport app.
What is the one I like from Autodesk?
InfraWorks.
So if you want to put the actual scan in juxtaposition with the real world, that's pretty cool. And you can also do it in virtual reality, the live program they have.
Danny Bentley, I love your question about file size, because we have that issue all the time. And it depends on what scanner we're using where it affects it. So for this scan here, with your whole exterior, this was done with a Matterport on the inside, and then within the Matterport iPad app, I just turned on our BLK and we scanned the outside. So this is only like a couple hundred megabytes, which is nothing. Like, you almost can be emailed. And what I do is then I share with them the Matterport, this space detail, and allow them to go through it, so I don't have to send them any of the scan files. So it's all done via OneDrive for us. But I know what you're talking about with the BLK. I've had up to 20, 50, 100 gig files, and unfortunately for us, right now, like we will buy like a physical hard drive and send that because there's no way to share that much data through OneDrive. So we provide our clients with either a thumbstick or, depending on the size, that bar we bought a external hard drive, and we just provide that to you so you have it and it's not taking up space on your computer, and that's been a great system for providing those huge files. But anything 10,000 square feet and under, I would personally recommend doing the Matterport and BLK360 combo, and then you don't have to worry about the file size.
Approximate cost to scan a 2K house using Matterport? Email me.
We're going to go over how to get a hold of us at the end. Don't worry. So, Mustafa, I'm seeing you cannot get the slab and beam depth if there is a ceiling. That is true, but you are able to get closer than you would be able to. And I want to show you guys, if I can open this section view. So you can actually see in here kind of, I mean, this is a house, so, but your slab thickness or your framing thickness. And when you go into 3D, if I can open up a section box here. So I'm going to close that in and then bring it in that way. So you can see in this basement here that there was actually wood joists, and we were able to capture that data with the scan as well as some duct. And this is a lot better than nothing, in my opinion. And like, you're still able to calculate the distance between these floors where there was a ceiling too. So I hope that kind of answers your question. You are correct. If there's floor and ceiling, you're not going to be able to get in between them.
Is there any discussion of initial alignment,
I would
elevation, project north orientation?
I typically will look up the house on Google Maps and figure out that northwest, southeast orientation and orient my Revit model to that. And like we said, if you want to use InfraWorks to actually nail down that location, you can as well.
How do you clean up the scan so you only have the envelope partitions on the scan?
So Recap Pro is what you're going to want to use to clean it up. And let's see if I can open that without destroying my computer. It may happen. So in Recap, when you're viewing the full... no, not going to be able to open it. Anyways, when you're viewing the scan as a whole, you're able to actually kind of highlight over, and this is Revit, but in Recap you can grab chunks, like if there's too much tree, highlight it like that, and just hit delete on your keyboard, and then it's gone. So that's like Recap Pro is the best way to clean up even a Matterport point cloud scan.
All right.
So we're seeing some conversation about the Matterport accuracy and BLK accuracy, and yes, there's going to be a little more inaccuracy with the Matterport, but from like field verifications that we've done, and we've seen, like I said, a 2,000 square foot house, you're probably not going to have much issue. I mean, we've been dead on most of the time with our Matterport scan, but as I was saying, when you get into 20,000 square feet or giant, big open spaces, then yes, like the BLK 360 is totally the way to go.
What about stuff with like tons of detail?
Tons of detail. I would probably like, if I was doing like a mechanical room, I'd probably use the BLK 360. It just depends on what the project is. A small house, I would use the Matterport just because of time and ease. A more complicated project, I always go with the BLK 360 to get that accuracy.
All right. Is there a way to split large files into 2 or more files?
Yeah, so I've done that before, and basically when you scan, the BLK would be the only like where you're going to have that issue. The Matterport file is capped at 10,000 square feet. So what I've done is I would scan, let's just say the main level of the BLK as one project, and then have that separate. And then I would start a new scan that just had some overlap, like between a doorway or something, and then have the separate scan. And then you bring them into Revit as two separate, smaller point cloud files. And then you can align them where the overlap is in Revit, and that'll save you a lot of space if you need to split those files up.
Very cool. Have you scanned and modeled facilities with piping and equipment?
Yes.
Yes, we have.
Yes, absolutely. You can, and we do, and it's super helpful, especially if you were to use the BLK out there and get all the details of a mechanical room. Or and also the BLK will work. You can't see, but above us is acoustical ceiling tile. You can pop those tiles out and put the BLK up
Don't
there.
tell them that.
Yeah, you can pop the tiles out and you can put the BLK up there, and you can spin it around and scan it and move it around and actually capture that ceiling space and see where everything is.
For as-built documentation, can you align to a BIM model?
Yes. Yeah, I mean, you can do it either way. Like if you have an existing floor plan, you can take that point cloud and align it to it, or you can use the scan to create your new as-builts. I would do that inside of Revit.
That's all the questions we had. Do you have any more? Is there anything else you want to show us?
I feel good about this. I
Yeah.
know you had a little bit you want to talk about at the end.
Just one last thing. So, of course, it's going to be difficult on me. All right, so we have a new client discount when you purchase prior to December 14th. So we're going to give you 50% off all Matterport scans. That's for the scanning itself, and then 30% off for BLK scans. So email me, Cassandra at onpointscans.com prior to the 14th. I'll get you pricing. And
Yeah, no.
and then you'll get to work with both of us.
Yeah, and then we'll both be there making this happen. Dynamo and Revit.
Well, go ahead.
Dynamo and Revit help the modeling process. That is a great question. I'm not sure on that right now. And email Cassandra your email address, and we'll get back to you on that. We'll find the answer for you. But I want to leave that up for a little bit and make sure your face is in the way of your email.
Oh, well, we can fix that, I think.
Maybe. But I think everyone gets the gist of it. So, the last thing that we wanted to talk about too, and we really want to thank everyone for taking the time to spend with us today. It's been a lot of fun going over this with you. Do you want to talk about memberships or anything?
Oh, yeah, absolutely. So, on the OnPoint Scan side, we have a free membership with a bunch of awesome resources for you. We have training videos, Dynamo scripts, a community forum, and more. And it's completely free.
Got a great blog.
Great blog. Tons of free information. Go there, sign up, learn.
Yeah.
And keep on watching our lab lives.
Yeah,
Awesome.
no, and we'll be back soon, and just really appreciate everyone taking the time to spend with us today.
We did get a couple more questions. How do you convert 3D scan into a mesh with textures that could actually be rendered in Inkscape? Maybe too off topic.
I might need a little bit of clarification on that. Rendering a point cloud, I'm not that familiar with that process. You're gonna find it. Rick, we need to look into that. So anyone who has questions about Dynamo and point clouds, just email Cassandra, and we're gonna find out the answer to that and get it back to you. Because I know we have plenty of people at Evolve Lab that know a lot about Dynamo.
Did you read the...
Yeah.
Okay.
I think we're good.
All right.
I think we've done it.
Thank you all for joining us. It's been great. Have a great day.
Thank you guys. See you soon.